Hi, welcome to the next video. This is homework 8. Um, so for 6.1.4, the first problem we'll look at is number 1 there. So x is a discrete random variable with this given probability function. Find e of x. So f of x is your probability function. It's 1/9 for x equals -3. It's 2/9 when x is 0. And 6/9, which is 2/3, for x equals 6. Find e of x. Okay, so let's find e of x, the expected value of x. E of x is the sum over x of x times f of x. That's equal to, well, when x is -3, it's times f of -3, which is 1/9, plus when x is 0, times the probability when x is 0, which is 2/9, plus when x is 6, times the probability that x is 6, which is 6/9. Okay, and so this is -3/9, which is -1/3, plus 0, plus 6 times 6/9, which is 6 times 2/3, which is 4. Or 6 times 6 is 36, 36 over 9 is 4. Okay. So -1/3 plus 0 plus 4 is -1/3 plus 4, which is 3 2/3, which is 11/3. 12/3 minus 1/3 is 11/3. So the expected value of x for number 1 is 11/3. Okay, so that's number 1. Keep going. So number 2. So for number 2, it says find capital E of x if x is the sum, the sum of the numerical outcomes of 2 rolls of a die. So x here for part A is the sum when you roll the die twice. Find E of x. Okay? So when the sum of 2 rolls of a die, well, what are the possible values of the sum of 2 rolls of a die? Well, the smallest sum is 1 plus 1, which is 2. And the largest sum is 6 plus 6, which is 12. And so it goes 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Those are all the possible sums of 2 rolls of a die. And so for each of those, what is the probability that the sum is that amount? Well, the probability the sum is 2. There's only one possibility, 1 plus 1, 1 and 1, which is 2. And there's 36 different rolls. There's 36 possible rolls of 2 dice. 6 of the first roll, 6 of the second roll, multiply them, you have 36. So 1 out of 36 ways, the sum is 2. If the sum is 3, it's 1 plus 2 or 2 plus 1. That's 2 out of the 36. 4, it's 1 plus 3, 3 plus 1 or 2 plus 2. There's 3 ways. That's 3 out of 36. 5, it's 1 plus 4, 2 plus 3, 3 plus 2, 4 plus 1. There's 4 of those. That's 4 out of 36. 6 is 1 plus 5, 2 plus 4, 3 plus 3, 4 plus 2, 5 plus 1. There's 5 of those. 5 out of 36. 7, there's 6 ways. 6 out of 36. 8, there's only 5 out of 36. 9, probably the sum is 9 is 4 out of 36. Probably the sum is 10 is 3 out of 36. Probably the sum is 11 is 2 out of 36. And probably the sum is 12, there's only one way. 6 plus 6 was 36. That's 1 out of 36 dice rolls. So the probability is 1 out of 36. So these are the probabilities that the sum is 2 through 12 when you roll 2 dice. And so what is the expected value of x? It's a sum of all possible values of x times f of x. And so for each value of x, you multiply by its corresponding probability, and you add up the products. And so you get 2 times 1 over 36, plus 3 times 2 over 36, plus 4 times 3 over 36, plus 5 times 4 over 36, plus 5 times 4 over 36, plus 6 times 5 over 36, plus 7 times 6 over 36, plus 8 times 5 over 36, plus 9 times 4 over 36, plus 10 times 3 over 36, plus 11 times 2 over 2 over 36 plus 12 times 1 over 36. Okay, and so you multiply each of those and you add up the products. And so you get 2, I'm going to multiply the numerators and add the numerators. So you get 2 plus 6, which is 8, 8 plus 12, which is 20, 20 plus 20, which is 40. So there's and 40, 70, 112, 152, 188, 218, 240, 252. So it's 252 over 36. And so, so that's 7. Okay, because 7 times 36 is 252. 7 times 30 is 210. 210 plus 42 is 250. 7 times 6 is 42. 210 plus 42 is 252. So 252 over 36 is 7. So the expected value is 7. Which makes sense. 7 is in the middle. Right? Between 2 and 12 is 7. There's a symmetry here. So we should expect, it makes sense that the value is 7. So I added those 11 products correctly. Okay, and you get 7. Let's see. Let's go from let's go to the next section. Okay, next is 6.2.3. Okay, for 6.2.3, let's look at number 1. So for 6.2.3, number 1, if player A plays player B $1, $1, when the outcome of the die is 1, 2, 3, 4, or 5, then in order to make this a fair game, what should player B pay player A when the outcome is the 6? So we want this to be a fair game. So what we want is that the expected value to be 0, where x is the amount A pays B. Okay, so the amount A pays B, that's x. Okay, so the expected value of x, which is 0, is equal to the sum over all possible values of x times f of x. And so one possible value of x, the amount A pays B, is $1, right? And so that $1 is times the probability, which is 5, 6. 5 of the 6 numbers are numbers that when you roll them, A pays B $1. So there's 5, 6 chance of that. Plus, well, if B is paying A a certain X dollars, a certain amount of dollars, then what I would say is that it's negative C many dollars that A is paying B. Okay? And so then I'm going to say, what's the probability of that? That's 1/6. That's 1 out of the 6 numbers that happens. And so that sum of products is 0. And so that implies that C over 6 is equal to 5, 6. So that implies that C is 5. So what that means is that C is the amount that so negative C is the amount A pays B if you roll 6. So C is the amount B pays A when you roll 6. So B pays A $5 when the outcome is a 6. So the answer is $5 right there. Okay, and so that's the answer to number 1. of 6.2.3. Okay, so let's go to the next section. So 6.3.2. Okay, so for 6.3.2, number 1, let capital X be a random variable with the probability function given by that f. Okay, so you have 0.1 for x equals 1. 0.4 for x equals 4. 0.5 for x equals 9. Okay, so that's probability function, and so you want to find a few things. Let's find e of x squared. So the e of x squared is the sum of all possible values of x squared f of x. And so that's equal to, when x is 1, you get 1 squared times f of 1, which is 0.1, plus 4 squared times f of 4, which is 0.4, plus 9 squared times 0.5, which is f of 9. Okay, and so that's equal to 0.1 plus 4 squared times 0.4 is 16 times 0.4, which is 0.64. Because 4 cubed is 64, but it's, wait, actually, it's 16, 6.4. 6.4. Because you have 16 times 0.4. 6.4 plus 9 squared times 0.5, that's 81 times 0.5, which is 40.5. Okay, and so you add those three up, and so you get 6.5 plus 40.5 is 47. Because 40 plus 6 is 46, and then you get 0.5 plus 0.4 plus 0.1, which is another 1. So 46 plus 1, 47. So e of x squared is 47. Okay, next, e of x to the 1/2. And that's equal to the sum over x, the sum over all possible values of x raised to the 1/2 f of x. And so what that's equal to is, well, you have the square root of 1 times f of 1, which is 0.1, plus 4 to the 1/2 power times 0.4, plus 9 to the 1/2 power times 0.5. And so that's equal to 0.1 plus square root of 4 is 2. 2 times 0.4 is 0.8. Plus the square root of 9, which is 3. 3 times 0.5, which is 1.5. And so that's 2.4. Okay? Okay, so e of x to the 1/2 is 2.4. And then e of 2x to the 1/2 is equal to the sum over all possible values of x of 2x to the 1/2 f of x. Okay, well, 2x to 1/2 f of x, well, that's just equal to 2 times the sum over x of x to the 1/2 f of x. You just move the 2 out of the sum. You're adding terms where each term you're saying 2 times something, and so you just 2 times the sum of the rest of the stuff. So this sum, we already said, right? That sum is 2.4. That sum is 2.4. So it's 2 times 2.4, which is 4.8. And so e of 2 times x to 1/2 is 4.8. Okay? Okay. Okay, so then that's that one. Okay, so we did at least one problem in each section. Let me do another problem. Okay, so 6.1.4, number 3, with that one. For that one, it says find the expected number of aces in a poker hand of 5 cards. So the expected number of aces is the probability of an ace times the number of cards in the hand. And so the probability of an ace is just 4 over 52 times the number of cards in your poker hand. And so that's just 20 over 52. In simplest form, that can be 10 over 26, getting simpler, 5 over 13. And so the expected value of aces is 5 over 13 as a fraction. Okay? Okay, so let's stop there. I'll see you next time.